There is an ocean on Jupiter's moon Europa containing more than twice as much liquid water as every ocean on Earth combined. It has never seen sunlight. It sits under kilometers of solid ice, and NASA confirmed the ingredients for life may exist there right now. A spacecraft is already on its way, and it will arrive in 2030. I remember the moment I first understood what Europa actually is, not a frozen dead rock, but a world with a warm, dark, saltwater ocean that has existed for billions of years completely untouched. That thought genuinely unsettled me in the best possible way. Europa is one of Jupiter's 4 largest moons, discovered by Galileo Galilei in 1610. It is slightly smaller than Earth's moon, but what is underneath its surface makes it one of the most extraordinary objects in the solar system. Beneath Europa's icy shell lies a global saltwater ocean, confirmed by NASA's Galileo spacecraft in the 1990s through magnetic field measurements, showing the ocean conducting electricity like a giant wire. NASA confirmed this ocean may contain more than twice as much liquid water as all of Earth's oceans combined, making Europa, not Earth, the largest ocean world in the inner solar system. Europa's icy surface is one of the smoothest in the solar system, very few craters, which tells scientists the ice is geologically active and constantly refreshing itself. Something underneath is moving it. Scientists estimate the ice shell is between 10 and 30 kilometers thick, but they are not certain. One of Europa Clipper's primary instruments, the ice-penetrating radar, will measure this precisely for the first time during its 49 flybys. The uncertainty matters because if the ice shell is thinner, it is more likely that material from the surface can reach the ocean below, and that material from the ocean can reach the surface above. Europa's ocean is estimated to be 60 to 150 kilometers deep, far deeper than any ocean on Earth, where the deepest point is about 11 kilometers. It sits in complete darkness, under crushing pressure, with no sunlight reaching it. The ocean is saltwater, confirmed through spectroscopic measurements of Europa's surface salts. Scientists believe the water is in direct contact with the rocky seafloor, which is critical for the chemistry that could support life. In January 2026, new research published in Earth Sky confirmed that salty, nutrient-rich surface ice can become heavy enough to break free and sink through Europa's icy shell into the ocean, delivering fresh chemistry from the surface directly to the water below. On Earth's deepest ocean floors, hydrothermal vents release superheated water rich in minerals and chemicals, and entire ecosystems thrive around them with no sunlight whatsoever. Bacteria, tube worms, shrimp, and crabs live in complete darkness, sustained only by chemical energy. Scientists believe Europa's rocky seafloor may have the same type of hydrothermal activity, driven by the tidal flexing of the moon as Jupiter's immense gravity pulls and compresses it in every orbit. This tidal heating, Jupiter squeezing and releasing Europa like a stressed ball, is what keeps the ocean liquid despite Europa being 780 million kilometers from the sun. The heat comes from gravity, not sunlight. NASA's Galileo spacecraft, which orbited Jupiter from 1995 to 2003, made the observations that turned Europa from an interesting moon into the solar system's most compelling target for life research. Galileo detected a magnetic field around Europa that behaves exactly as a saltwater ocean conducting electricity would behave, a rotating, conducting layer responding to Jupiter's own massive magnetic field. This was the confirmation of the ocean. Galileo also photographed what appeared to be surface disruptions where warm ice from below pushed through the crust, features scientists call chaos terrain, suggesting the ocean and ice shell are actively interacting. NASA's Hubble Space Telescope detected what appear to be water vapor plumes erupting from Europa's surface, similar to the confirmed plumes on Saturn's moon Enceladus, observed multiple times between 2012 and 2019 if confirmed. These plumes mean Europa is actively venting its ocean water directly into space, and a spacecraft flying through them could sample the ocean's chemistry without ever needing to land or drill through the ice. Europa Clipper carries an instrument called the Surface Dust Analyzer, specifically designed to fly through any such plumes and analyze their chemical composition in real time during its close flybys. NASA's Europa Clipper launched on October 14, 2024, the largest spacecraft NASA has ever built for a planetary science mission. It completed a Mars Gravity Assist flyby on March 1, 2025, and will swing past Earth on December 3, 2026 for a second gravity assist. Europa Clipper will arrive at Jupiter in April 2030 and perform 49 close flybys of Europa, each one using all 9 science instruments simultaneously, building up a comprehensive picture of the Moon with every pass. In August 2025, Clipper's ice-penetrating radar completed a critical test flyby of Mars, the first time this instrument operated in deep space, and Science Daily reported the results exceeded expectations, boding well for Europa. Europa Clipper is not a life detection mission. NASA has stated this clearly. Its goal is to determine whether Europa's ocean has the conditions that could support life, what scientists call habitability. The 3 things Clipper is measuring are how thick the ice shell is, what the ocean's chemistry is, and whether the geology shows active exchange between the ice and the water below. All 3 are required for any chance of habitability, NASA astrobiologist Steve Vance stated directly. It is almost certain Europa Clipper will raise as many questions or more than it answers. This is honest science, not a promise of discovery, but a commitment to genuine investigation. Scientists use 3 criteria for any environment that could support life: liquid water, a source of energy, and the right chemistry, specifically carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Europa has confirmed liquid water. It has a confirmed energy source through tidal heating and possible hydrothermal activity. The chemical question, whether the right elements are present in the ocean, is precisely what Europa Clipper's spectrometers are designed to answer. On Earth, every single environment where liquid water and chemical energy exist together has been found to contain life. That pattern, confirmed across thousands of extreme environments, is what drives the Europa investigation. Mars once had liquid water on its surface, but lost it billions of years ago. Europa's ocean has existed continuously, in direct contact with rock, for an enormous period of time, giving any chemistry far longer to develop. Europa's ocean is also protected from surface radiation by its thick ice shell, unlike Mars, where the surface is bombarded by solar radiation with no magnetic field to protect it. The ocean is shielded. NASA describes Europa as one of the most promising places in the solar system to search for life outside Earth, a statement used officially across JPL, NASA Science, and the Europa Clipper mission documentation. If Europa Clipper's 49 flybys confirm the ocean is chemically rich, the ice is actively exchanging material with the water, and hydrothermal vents are likely present, NASA's next planned step would be a lander mission to drill through the ice. A Europa lander has already been studied by NASA in detail. A 2016 Science Definition Team report outlined instruments it would carry, including a life detection suite. No lander has been approved or funded yet, but the studies exist. The Europa Clipper data arriving from 2030 onwards will be the deciding factor. It will either confirm Europa as a priority target for a lander or reveal conditions that make habitability unlikely. That answer is coming within a decade. Europa is not a long-shot guess. It is the best evidence candidate for a potentially habitable environment beyond Earth, confirmed by the Galileo mission, supported by Hubble observations, and now being investigated by the most capable planetary spacecraft NASA has ever launched. Whether Europa hosts life or not, the answer transforms our understanding. If yes, life is not rare in the universe. If no, we learn exactly what conditions are missing, which sharpens every future search. Europa Clipper is already flying. The data is coming. The most important scientific question humanity has ever asked, are we alone, may be answered, at least in part, by a frozen moon orbiting Jupiter. That is tomorrow's science.